Good morning, everyone, and welcome to ITPro Dev Connections 2020. Thank you for being here during this pandemic, and I'm very glad to be keeping you company for the next hour. Before we begin, I want to say a big thank you to all of our sponsors that made this event possible, and especially to our communities. That helped a lot with the volunteers and that are going to be making sure this weekend runs smoothly and helping us speakers deliver our content in the best way possible. So thank you very much. So in this session, we're going to see how to use Azure AI on premises by user Docker. I am Georgia and I'm going to be your speaker for the next hour. Feel free to share to the social media. Don't forget to use the hashtag ITProDevGreece and spread the joy. A little bit about me. I am a Microsoft MVP in AI. My day job is web applications developer at ITT.inc, and I'm a Microsoft Learn Ambassador. In my free time, I love blogging, traveling, at least before the pandemic, and I love speaking and doing workshops and technical trainings. You can see my blog, codestories.gr, for any articles regarding cognitive services and machine learning and AI if you're interested, and follow the page in Facebook as well. Otherwise, you can find me in LinkedIn, find my code repositories in GitHub, or follow Twitter for more information. So, today's agenda, we're going to see a little bit what Microsoft Cognitive Services are and how can we use them. I'm going to give a brief introduction to Docker. Hopefully all of you know it, and if it sounds interesting enough, you can go ahead and research it further. We're going to talk a lot about Azure Cognitive Services containers and how we can deploy and configure them and use them with Docker on premises. I'm going to have a live demo to show everything we're going to be talking about, and you can send your questions in. I'm going to try answering as many of them as I can at the end of this presentation. So, I always love definitions. So, to start, AI is any technology that appears to emulate human performance and behavior, and it does so by exhibiting learning. It can make decisions and come to its own conclusions, and can understand complex content, communicate and engage in natural dialogue, and it is used mostly to enhance human cognitive performance or assist people on the execution of tasks that normally would take a long time for a human to perform. So this is actually what Microsoft Cognitive Services does. It helps us developers give our applications a human side, be smart, understand natural language, make decisions, and make our lives easier. So what it actually is a set of ready-to-use APIs for developers without requiring any machine learning expertise, which is really helpful for people starting out in AI or new developers, because machine learning requires a lot of data science concepts and it requires a lot of data. So having a first step that doesn't require you to have this knowledge is very helpful and can accelerate development for a lot of applications. Of course, Microsoft Cognitive Services do have pre-trained models for the most part. So I would like to say that while they can be very helpful and help you develop applications very fast, they might not fit every scenario you have. So see the overview, see what the APIs provide, and there are also some custom services that you can develop and customize to your own or your organization's needs. So there are a lot of cognitive services APIs currently available in these 6 categories for knowledge, language, speech, machine learning, vision, and search. There's text analytics. You can analyze text, detect language, find sentiment. There's anomaly detection, so you can find anomalies in your data. You can have a recommendation API where it recommends or creates lists or helps you create a timeline customized um, to your user's preferences. There's of course search, the computer vision that helps recognize content in images and videos. There's sentiment scoring, emotion API. I could be talking for all the available APIs all day, so I urge you to go ahead and search for Cognitive Services API and find the available documentation and how you can test them. So let's go on to Docker. For those of you who don't know, Docker is a containerization platform. It is usually used to develop, ship, and run containers. Docker doesn't use a hypervisor, necessarily, and you can run Docker on your desktop or your laptop at your house while you're developing and testing applications. The desktop version of Docker supports Linux and Windows and Mac OS, and it consists of several components that we can use to run and manage our applications. So in essence, Docker runs on top of any host operating system. So it's not the developer's job to know the hardware requirements or the additions or if his or her application is compatible. You just focus on developing the application and you can host it with Docker and then it can be deployed to any platform as long as the infrastructure supports it. So it's very easy and fast to deploy whole workloads just by using a script. Today, when we think about production system, Docker is available for server environments, including Linux, Windows Server, and actually cloud infrastructure. For example, Azure has a very good support for Docker if you need it. When we're looking for localized development or testing, local Docker Desktop for Windows, which is what I'm going to be using today and later in the demos, is a Windows application, a native Windows application that provides an easy-to-use development environment for when you want to build and ship and run your Dockerized applications. So Docker Desktop uses Hyper-V, the Windows application, and networking, and it's a reliable way to start developing Docker application on Windows. At this point, I should note that Docker Desktop on the Windows application does support Windows or Linux containers. So you're not limited by, because you have like a Windows infrastructure, Windows laptop that you use for development, that you can't use Linux containers and you'd require a Linux hub. You can run Linux container on Docker Desktop for Windows. So that's very easy and very convenient if you're a developer. Although Docker Desktop does have some features and an easy to use interface to do some things, generally I prefer to use the CLI to do every Docker function. We're gonna have to see it a little later anyway. Another thing we're gonna be talking about today is the Docker Hub. Docker Hub is a software as a service Docker container registry. Docker registries are repositories, in essence, that we use to store and distribute the container images we create. So Docker Hub is the default public registry Docker uses for image management. So keep in mind that you can create and use a private Docker registry or use a cloud provider to create your own Docker registry. For example, you can use Azure Container Registry to store Docker containers for use in many Azure Docker-enabled services, of course. So in the Docker Hub, we can see that there's already Azure Cognitive Services images available, and you can use them in order to pull those images and create your own image locally to run. So let's go ahead and see the topic of the day: how to use and deploy Azure Cognitive Services containers. So there are a lot of Azure Cognitive Services containers for the following services: anomaly detector, optical character recognition, spatial analysis API, the face APIs, form recognizer, the language understanding, speech service API, and text analytics API. Not all of those categories features are supported, but a very large subset of those services does have support for containerization in Azure Cognitive Services images. So, and a lot of them are being published every day. So, if your feature is not yet supported, please wait a little bit, and usually it will be in the near future. So, why should I go ahead and skip the Azure APIs and use Docker and containers? There are a lot of benefits to doing this. First of all, there is immutable infrastructure. You can leverage a consistent and reliable set of known system parameters, and you can easily adapt to change. Containers have the flexibility to work within their own ecosystem, and you can avoid any configuration issues you might have otherwise, etc. This is the most frequent question I have regarding the Azure Cognitive Services API the first time someone hears about them. Like, what happens to my data? Here I'm going to make a little detour and just say that Azure is fully compliant with all Europe and US and the whole world regulations regarding data protection and privacy. You can go to the Azure compliance page and see all the certifications Azure has regarding how it processes data, how it stores data, how long it stores data. You can find the information of how much each service stores your data and what does it do with it. Microsoft does not use your data for marketing purposes. It just uses them to improve their services in a way that they're not compromised, doesn't actually read your data or have any issue with it. Having said this, though, there are still a lot of people that are hesitant to upload their data to the cloud just because they feel like they have no control over them. So, and there are people that are not allowed by government or other regulations to have data in the cloud. One sector I can think is the medical sector. Some medical data are very sensitive and confidential and might not be allowed to exist in the cloud. So if your organization or you have any customer that has this case, this is a very good solution for you. You have complete control over your data. You can choose where your data gets processed by Cognitive Services. So if you still need access to Cognitive Services API but can't send data to the cloud for any reason, you can have fully data management, identity, and security over your data. So if you have any regards on this, you can sleep safely today. Your data are safe. One thing that is very important as a feature of using containers and images is that you have full control over model updates. So far in Azure, you don't have control over which version of the API is currently available. So there could be some cases where you have to change your either authentication or your model because Azure is updating its service to a newer version, which is very difficult when having large organizations with big workflows and a lot of processes in place. So now you have complete control over model updates. You have flexibility in versioning, and you can update your models deployed in your solution when you want. So you don't have to even think about this. Of course, this is a benefit of containerized applications in general. You have portable architecture. Nothing ties you to a certain provider, whether that provider is on-premise or that provider is a cloud provider. You have a portable application architecture that can be deployed anywhere, whether that is Azure, whether that's on-premises, or other solution like Kubernetes service, Azure Container instances, Azure Stack, or anything you can imagine. So you have complete control over your architecture. You're free to focus on developing the application itself. There is the ability to have high throughput and low latency. So the good news is that containers do not cap transactions. So they can be made to scale up or out to handle your demand as long as you provide the necessary hardware resources. So it can, similarly to Azure, it's very flexible to scale and manage and process big or small workloads as long as there's a hardware infrastructure to do it. And of course, scalability, as I've said, well, containers are very popular. A lot of technologies are still popping up and getting better with each passing day. So you can build on a scalable cluster foundation, and your application is highly available out of, let's say, out of box, but not completely. You have complete control over it. So, in order to work with Azure Cognitive Services containers and Docker, there are some prerequisites. Firstly, you should have an active Azure subscription with active Cognitive Services key. I'm going to explain that in depth a little later, but to sum up, Cognitive Services are not licensed to operate offline completely. So you would need an active subscription and active keys to that subscription in order to use Azure Container Services. You should have access or create a Docker engine, either on premises or on Azure or anywhere you want, that is configured to connect to Azure. You still have to maintain connectivity with the Azure service. And of course, you really must have a basic knowledge of Docker, Docker Hub, Docker Desktop, Docker Commands, and Microsoft Container Registry, how to pull images, how to create those images, build them if necessary, etc. So these are the prerequisites of working with Microsoft Container Registry and Docker. So the first step is to get the images. You can get the link to the images from either the Docker Hub or the Azure Docs. So you would use the Docker pull command to get the container image. This particular pull command gets the text analytics language image, the latest version available, which is the version we're going to talk about today in our demo as well. Then, as soon as you have the image, you can use Docker run to run this container and have it readily available. Well, as you can see in the command, there are several configuration parameters you would need to run this container. I can't stress enough how important those three configuration parameters are. The API key, the billing endpoint, and the EULA agreement acceptance parameter are mandatory for your container to run. Without those three parameters, the container is not going to run at all. So before you have the images, make sure that you have created an Azure subscription, you have your keys ready, your billing endpoint ready, and you can then go ahead and start working with Docker. Okay, as you can see in the parameters, there EULA, you have to put accept. Billing, you have the endpoint URI. You will get this from Azure portal, and the API key, which you are also going to get from the Azure portal. So please do not forget those three parameters. Of course, they're not the only parameters you're going to use. Besides the three mandatory ones we can see on top, you can use parameters for application insights. Application insights adds telemetry to support your container and see how it's been used. You can use FluentD, it writes logs and optionally any metric data you wish to a FluentD server. You can configure an HTTP proxy for making outbound requests. If you're using ASP.NET Core, there's logging support for your container. And generally you can use commands to read and write data either from the computer container, the host computer to the container, or from the container to the host computer. And there are also parameters for CPU requirements or anything else like this. So you keeping that in mind, for each service there are different parameters. You can configure your service to run as you want. Another very important thing is the container networking. For the Azure Cognitive Services container to work, you would have, besides any other networking requirements you have for your project, you should allow list port for 443, and they should access the domain cognitive.microsoft.com and cognitiveservices.azure.com. This is because Cognitive Services containers are not licensed to run without being connected to Azure for metering and billing purposes. So developers need to enable those containers to communicate any billing information with the metering service at all times. Cognitive Services do not send any data to Microsoft, as I've said before. So the text, let's say you are using to translate in the text analytics, or the recording you used to convert speech to text are not sent to Azure. Only metering and billing data are sent over to Azure. But for that, you need to maintain connectivity with Azure at all times. Some containers might have extra requirements. Take a look at the docs for the API you're using. Let's take the first row here, for example, have some random requirements where if you're looking to do language detection or let's say key phrase extraction, okay? The minimum host specs this service requires is 1 core and 2 gigabytes of memory. The recommended for Microsoft is 1 core and 4 gigabytes for memory. But this is not fixed. You might have to give more resources if you have more connections or multiple apps connecting to this API. So make sure you give the necessary hardware infrastructure to each service or API you are using, so they can run properly and you don't have any throttles or delays or timeouts when requesting and accessing the API. This is, for example, in the Docker command, the memory, how you would declare the configuration for memory and CPUs. This example has 4 gigabytes of memory and 1 CPU assigned, which is the recommended host specs, let's say, for the text analytics language. Okay? Of course, what if you have multiple containers and you don't want to pass the arguments every time you run the container? You can definitely configure your container for use. What you would do is create a Docker file and build the image from this. So you would still get the image from the Docker Hub and the Azure Container Service, and then you would declare the arguments for the API key, the billing, and the EULA acceptance. Then all you have to do is declare a couple of variables that take that build and run it as a build image. Then you would run your own image that was built from this Docker file along with the arguments. So no worries there. As far as security goes, you're gonna notice that when you take the Azure container images, there is no security or authentication whatsoever. So please do not take the Azure Docker image and just publish it, either locally or in a server or anywhere else. Because as we can see in the left side, in the left image, I know it's not very legible. This is the non-secure way where you just download the image and you host it in a Docker container, then you publish the container, and this is free to be accessed from the internet. Besides security, you can incur larger costs because someone else has found your APIs using it. There are many ways to secure your application. And the reason this is unauthenticated and unsecure is because it is assumed that this workload is hosted either in a cluster or in a server with its own network security requirements for your application, where users are probably either authenticated or the app is already configured to use the application from people or apps that are authorized to use it. So the images are not secured by default. And when you have like a cluster this is in, or when you're using it in Azure, there's usually a virtual network in place and a lot of security, so you don't need to do it individually on the container. If that's not your case, then you might have to think of a security system in place to operate. As we can see on the right hand image, this is one example of having a secure container that connects to the internet through an ingress gateway, and the applications are either isolated or encrypted. The communication between applications is encrypted with, let's say, SSL. Okay. There are a lot of deployment options. As I can say, as I've said, there's on-premise server with Docker Engine installed, so you can have everything completely configured and on premises. So just metering and billing data are communicated outside of your organization or your setup. But if you ever decide to change, or the requirements need a different environment, you can always use Azure Container Instances, the Azure Kubernetes Service, or you can publish it to the Azure Container Registry and have it either public or private, depending on your needs. Okay? So, I think I've talked a lot so far. I've explained all possible options. It is time to see how these things work in action. So I'm going to be using the Docker desktop. This is the user interface. Currently there are not containers or apps running. And these are the images I've downloaded, and you can see some fast information. As I said before, I don't really use the UI interface for this. I prefer to use the CLI command. So we're going to use PowerShell for this. And before we see it in action, I'm going to show you the Docker Hub. So you can go to hubdocker.com, create an account. There's a free tier, and there are multiple things you can use to test and experiment. You can go to Azure Cognitive Services menu, and you can see all the feature repositories and what Links are there for each service. As I said, the anomaly container, the text analytics, language understanding, all of the services have that are available or in preview, and some information on the product, etc. You can also find all of this information in the Docker doc, in the Azure Docs, along with the links and anything available you would need to start creating. So let's go back to Docker Engine. I have a Docker Engine installed in my computer. I'm going to use the CLI. I'm going to be using Windows PowerShell. I know it's a little small, so hopefully you can see some things. I'm going to show the commands I'm going to be running here. So as I said, so there's better visibility. As I said, the first thing you should do is docker pull and get the language. So what I'm going to do here is find the docker pull command. What happened here? Just open it again. Okay. So the first thing you would run to get the image is docker pull. So I have run it before, so I have the latest version already here. And then I'm ready to run it if I want. As I said, the requirement to run my Docker image is the API key, the endpoint, and the EULA agreement acceptance. For that, I would need to go to Azure. So this is the Azure portal. From here you can create a resource, or you can see your recent resources if you have any. If you're new to Azure and haven't really seen it, you can open a trial account. It has a month free, some services free, and I think it has around $200 available for you to spend. So even if you don't have an Azure subscription, you can open a trial and experiment. So you can go ahead and try it if you want to. So I'm gonna need an API key. So I will create a resource. I will find the API key I want to create. So there are two options. You can go ahead and find the text analytics, let's say, key, and create this service. Oh, it takes a little bit of time. And you can go ahead and try and create this service in Azure. You have to have an active subscription, you give it a location, the pricing tier, you can find details on the pricing for each of it, and a resource group. Resource groups are used to not combine, but group and have your resources well organized. So you can go ahead, find the resource you want to create for the API you want to use, or what I'm going to do is find the Cognitive Services Global, let's say, API key. Essentially, this is a product bundle that helps you access multiple services with a single API key, and these have access to vision, language, search, and speech. So if you want to have one key to handle all your services, you must create a Cognitive Services key, and this is what I actually have created previously. So I'm going to go to my own resource group and show you how to get those keys. So as soon as you have created your keys, all you need to do is go to your dashboard and to the keys and endpoint tab. Here you can show your keys, you can copy them and find your endpoint. So these are the resources you need to create your run command. So I have my run command here ready for deployment. So this is the command. I'm going to give it 2 gigabytes and 1 CPU. I'm actually going to use the language detection service. So let's look at this command, the second command. I want it to run in the port 5000, 2 gigabytes, 1 CPU, the image I'm using, I'm accepting the EULA agreement. The billing is going to go to this endpoint, and the AP key I just took from the Azure service. So let's go ahead and run this. It's going to be the previous. It's going to verify the information and the parameters I've sent and start my image. So it's showing me the EULA agreement one more time. It's submitting it, and my application has been started. So let's go ahead back to the Docker desktop application and see how this goes. So now I have an active container here, and I can see that this is in use. Here I have some quick links. You can open in browser or open the CLI as well. Stop, start, or delete your image. So I used it to go to localhost 5000. Obviously you can run as many containers here as you want, so you can have multiple APIs in different containers running at the same time. Just make sure that you have the parameters correct and they're running on different ports. So it's really impressive what we have here. You actually have the server, which is host your application, and the client, which you can use to find your application. So if you go to localhost 5000, now I can see the welcome page, the default Microsoft Azure welcome page that says my Azure Cognitive Service container is up and running. So yay, step one is down. I have pulled the container image and I have run it in Docker. There are some quick links here. You can visit and see the description. But all of APIs are accompanied by a Swagger. All developers know this. That Swagger is a tool that helps with API definition, and you can see the API you have, all the functions available. You can use them. You can use it to create documentation. You can use it to create mock servers. I'm just giving it a little bit of more explanation if we have people that are not familiar with it. And the thing is, you can also test your API. So it's a really fast way to test if what you have done actually works. So let's go and see if the image works as expected. If you don't know how to use your API and you don't want to use the Azure documentation, no worries. There's a lot of documentation already in the Swagger, so it says a little bit of description, what the SoStats parameter does. So I'm going to put it, I'm going to have to press try out first, so it can unlock the text fields, and I'm going to set this to true. So this is the body. The body is a JSON input. If I don't know how to use it, there's a model reference here. So we can open it and see that it requires a documents array, and the document array should have a country hint if we have like a country the text is coming from, so we can detect language. I don't know if I've said it. We're going to try and detect language in text in the container we worked. And here you have to set the country hint. This is optional, but you definitely have to set an ID that identifies the document, the phrase, the text you want to process, and the text itself. Okay? You can have one or more than one. I've prepared a query here. So it's the documents. I put 2. This is text 1. Hello everyone and welcome to ITPro Connections 2020. And the text 2, for my non-Greek friends, this is actually the same phrase in Greek as well. So let's see how the API is going to perform. I'm going to copy this and go ahead here. And let's try it out. I want true, I want the latest version, and I'm gonna put it here. And I'm going to execute, and hopefully, if everything goes well, Well, it did. I'm gonna have a response. I know the response is too small to read here. I'm gonna copy it and paste it here. I actually already have it, but I'm gonna post the updated one. Because I put the statistics value to true, I have some statistics. For example, how many document counts we have, how many valid documents. You can put something that is not valid, and it will throw an error. The errors can be seen in the end. It will inform you on their errors, and you can actually see the model version this has used to generate the results. So, the first text has a detected language of English and a confidence score of 1. So, yay, it is 100% sure. Confidence score goes from 0 to 1, and it's the percentage of how sure the service is of the results it's giving us. So it's giving us that the first is almost 100% sure that it's in English. And the second phrase, it has detected Greek with a 50% confidence score, which is actually accurate because half of the sentence is in Greek, the rest of it is in English. So in almost 10 minutes, we have pulled a Docker container, we have run it, and we have tested that it works correctly. And actually, that's it. That's how easy it is to use containers and to use Azure Cognitive Services on-premise as well. Then it's up to you to make the configurations and make the container secure, etc. I'm gonna note a little bit thing here. I know that the session is called Azure AI on-premise, but I think it's very impressive. Azure instances provide the same functionality out of the box. So if you want to create a new resource of Azure container instances, let's go here and let's go add, and I'm gonna put container instances. Container instances. Okay. If you don't have a Docker engine or a Docker environment, but you do have access to an Azure subscription, you can very well just create a container instance. You don't have access to the infrastructure, you don't care about anything, you just give it a name or region. There are quick start images, but you can use any Docker Hub image or any other registry. So I'm gonna take what I have here on this image, okay? And I can send it directly to the Azure Container instance. That's the beauty of it. It verifies that the protocol and the image exists. I can look for the OS type. I can change the size I want. I can even do networking on it if I already have applications in Azure, let's say, or virtual machines in Azure and have other services running on it, and Azure Directory, let's say. You can choose your own networking type that you already have in place to run this container. There are advanced configurations, so it can restart when it's on failure, or etc. You can have like environment variables, or you can override the run command, all of it completely. And that's what you need to review and create. It creates the container isn't that fast, and because I don't have time to create it right now, I'm gonna show you the one I've already created, that it's up and running with a text analytics image. I can have like, I have it on OS Linux, there's one container on it. I have all the metrics Azure supports. I can give identity, configuration, user assigned, or anything else, and I can manage it from the Azure portal. So there are a lot of options out there if you want to use the Azure APIs with the container with minimal effort on your side, and include them in your applications with full control on data, infrastructure, and anything else you wish for, network security, access, and any requirements your organization might have. So you're not limited by having a connection to Azure only. So I want to, and this is the final part of my presentation, I want to thank you very much for participating, and I hope you found it interesting. I'm going to try to answer any more questions right now if you want. Otherwise, thank you very much for being with me the past hour, and I hope you find the next presentation interesting and will be with us for the rest of the weekend. Thank you very much and stay safe. Good day. Bye-bye.